Michael McCoy takes the greatest of joy in the songs of the days long ago. He hears Annie Rooney and nearly goes loony, the tune of it tickles him so. His daughter Mary sings like a canary the popular songs of the day.
For those watching this in the future, this video was made in the year 2026. Those who were old enough to remember saw the old world order of the Cold War crumble some 35 years ago. For decades after that, a rosy picture was sold to the world public. It would be a bright future of open hearts and minds, a free flow of citizens of the world in a global village, as my own school books called it. But in reality, this proclaimed new world order would actually be built on open borders and open markets, the free flow of capital and cheap labor. This environment also furthered deindustrialization in the West and the loss of basic skills in the population. Cold War redundancies and resilience were given up upon to create a just-in-time economy with supply chains spanning the entire globe. And as we speak, we see a just-in-time military that runs out of ammunition, is unable to restock its own supplies, and even runs old equipment that it might be unable to fix. The machines needed to do that were scrapped, and the people able to do the job had been phased out. A big change, another paradigm shift is now happening once again. But most Western governments are sleepwalking into the future. Instead of rethinking the system entirely, they proclaim lukewarm half measures to soften whatever blow comes next. But there seems to be no plan. And that's because they believe in the system and wait for a back to normal that just won't come. So why has a guy called the post-apocalyptic inventor abandoned you in these times of need? Well, I haven't. I simply do what I always do when everything seems bleak. I hunker down and decide to finish in irrationally work-intense labor of love. When the systemic problems are so big that nothing feels like it makes a difference anymore, the only thing left to do is to simply pour your passion into something that will stand out to others and hopefully be an inspiration to them. And inspiration is exactly what I was lacking not too long ago when I thought about abandoning a project that I had started almost 5 years ago. So a few years ago I went onto a regular shopping spree in the German countryside. On that day I bought, among other things, this old lathe here. It looked really dirty and worn out, but that I thought would also make a really good restoration project then. I started work on the machine right away, but somehow I got stuck. I think because there was just too much wrong with it, or it seemed like that at the time at least. And over the years I had almost given up on the project and was frankly almost thinking about getting rid of it. However, after visiting a few interesting people and gaining new friends and seeing what they had been able to do with their own ingenuity and their own hands, I thought that it might be a good idea to refocus once again on building, modifying, and restoring machine tools. So I remembered this old project and I simply decided to finish it no matter what. And this is what this video will be all about. It'll feature footage from a time span of roughly 5 years. However, most of it was actually filmed over the past 2 months. So here is that 5-year restoration project. So after I had purchased the machine, the next thing I had to do was to disassemble it. I didn't yet own a trailer at the time and also had no one to help me with bringing the machine to my shop. That's why it was partially disassembled into various functional units that I could carry to my car. To make it short, after I had already taken the tailstock off of the machine, the ways were cleaned and oiled ever so carefully, and then the lead screw was taken off. These 2 steps were preparations so that I would be able to take off the carriage that carries the tool rest, cross slide, and so on. It is very heavy, and even 5 years later, I think it would have been wiser not to carry it alone. In the next step, the old electric motor and also an ancient automotive gearbox were detached from the lathe. These are modifications to the original machine. The final and probably heaviest part to be taken off is the headstock. These are often just held down by 2 or 3 bolts clamping into the machine bed. If you ever do anything like this, make sure to take pictures of which bolt belongs where and store the bolts together with the part you took them from. With these old machines, the bolts can be sometimes still non-standardized and you will have a hard time finding replacements if you lose them. In a final step, the cast iron legs and plinth were freed from the floor below. They as well were bolted to the machine bed and can be separated for transport. And with the help of the former owner, I was able to put all the parts into the back of my car and was able to bring them to their new home. Back at the workshop, the first thing to do was to take care of the largest parts of the lathe first. They take up a lot of space and storage, and it also makes sense to finish the support structure that everything else rests on first. And I started by taking care of the cast iron plinth. There were still remnants of cement that were removed with a chisel. This part was covered with thick oily grime inside and out. While it certainly preserved this machine to some degree, it also needed to be scrubbed off before wire wheeling, or else that oily goo would be thrown in all directions, sticking to my walls and windows, etc. And after all that, all surfaces were wire wheeled inside and out. When doing something like this yourself, make sure to wear a mask as well as eye protection, please. After that, the surface had been degreased as preparation for a new paint job. The cast iron legs received the exact same treatment. By the way, this style of lathe comes in different variations. The plinth was often used to store the change gears. But with many manufacturers you will find an identical version without plinth. The machine bed, with the ways on top, was covered in grease all around as well. But here we also found that typical amalgamation of hardened grime and metal chips. By the way, that workshop that this lathe came from was built in the 1930s and closed around 1975. Those chips were made more than 50 years ago, as that old workshop was in a Cinderella sleep since then. Over here, at a spot that was covered all these years, we also find what might be a remnant of the original paint job. So after scraping off the dirt, wire wheeling and degreasing, the ways and other spots that will remain unpainted are covered with tape. And the 3 parts of the support structure were then first coated in a layer of primer before a grey paint job was applied to all parts. So after the paint had dried, the 3 components could be reassembled, as I did here with the help of my self-made gantry. Looking at this, I know why I bought this lathe again. I think it has a very elegant style. But there also was a minor thing that needed to be repaired here. See, one of the pins on the 2 hinges of the plinth door had broken off. In order to fix this, I center punched the top of the broken pin, drilled it out, while doing that weakening it so much that I was actually able to drive it out. The hole was then tapped, and this bolt here was shortened and screwed into that hole and acted as a new pin now. This happened before I had actually repainted the door, as you can see here. But this simple fix was nothing compared to what lay ahead, because up to this point it was actually nothing but smooth sailing. Before tackling the bigger issues, there were a few other things that I needed to prepare for the lathe to become fully operational again though. I inspected the very rusty change gears that had unfortunately been stored on the wet floor of the old workshop. At first glance, the corrosion damage seemed really bad, and I wasn't sure if all of them could still be used. I tried to remove as much rust and debris as possible with wire brushes before the gears were then suspended in citric acid for a pretty long time. The biggest of the gears, with 127 teeth, was still attached to the lead screw when I had disassembled the lathe. The lead screw looked pretty ugly here, but it was actually in pretty good state. It wasn't very rusty at all and rather just covered in old brownish grease that had preserved it pretty well. The threads were cleaned with wire brushes and the cast iron parts that act as bushings for the lead screw were repainted. Now we had to take care of the much more complicated parts of the lathe. The carriage was very dirty and grimy and looked really nasty. A tool was still clamped in, by a tool holder that is clearly not the original though. I will demonstrate the different features of the carriage later in the video once it works again, but to make it quick, there is a hand wheel here that is part of a simple rack and pinion mechanism. The hand wheel simply connects to a pinion or small gear, and the rack is installed alongside the machine bed underneath the ways. It is used to reposition the carriage manually. On the inside we also see a half nut. It is basically a nut that is split in half, and its lever is used to engage and disengage the carriage from the lead screw. When you want to use the hand wheel, the half nut needs to be disengaged first. When engaged, the lead screw can move the carriage longitudinally or alongside the ways. Another lever called cross slide lever is used to switch the power feed from longitudinal motion to the cross slide or perpendicular motion. The cross feed can be used for automatic facing, parting, and so on. But while the screw inside the cross slide is still pretty tight and doesn't have too much slack, the screw of the tool post slide is in very poor condition. Or at least it is in the last 20 millimeters or so. The threads are completely worn out there. That is because that part of the screw is what would have seen all the action and it was under stress all the time, while the rest of the threads probably have never seen much action at all. All the parts of the carriage will have to be cleaned and repainted and greased, but the most severe damage is on this screw, so let's repair that first. The old screw will now be rebuilt. In order to do that, we will need the TIG welder, a thread cutter of the right size, and also, crucially, another lathe. Fortunately, I already restored another lathe around 10 years ago, which I have since been using here in the shop extensively for all kinds of projects. My first lathe is a somewhat modified machine made by the German company Kröner und Reimer in Leipzig-Lindenau in the 1920s. At the time of recording, I now actually own not 2 but 4 different machines. The 2 others are currently being restored as well. I hope you like machine tools because there's going to be a lot of lathe restoration content this year. In order to fix the old screw, it is turned down on one end until the old threads are completely gone. After doing that, a heat-resistant blanket was placed on the ways, and I started to add new material by welding and rotating the spindle by hand. And I did that until I had more than enough material to work with. In the next step, the welded-on steel was then turned down to the outer diameter of the old threads. I actually spent a lot of time to make sure that the screw runs as true as possible, but it is also warped and bent and needed to be straightened before it would fit in the end. Luckily enough, the threads on this ancient screw were already standardized metric threads, and I was able to find an off-the-shelf cutter for a few euros. This way I was able to repair the threads. The old Kröner und Reimer lathe could once be used for thread cutting as well, but the mechanism that was needed for that was no longer attached to it when I bought that machine. This style of lathe doesn't have a lead screw. The German name for these types of machines is Patronendrehbank. So after that screw had been repaired and all the many parts of the carriage had been cleaned, the slide was reinstalled. After degreasing and taping, the carriage once again received primer and a new paint job. It was operational once again, and together with the restored lead screw, it could be installed to the lathe again. To catch a break from restoring the much more complicated parts of the lathe, I took care of the tailstock next. The way that lever protrudes from the backside of the tailstock through that distinct looking slot seems to be rather rare, and I haven't really seen this in any other machine. If you have seen this style of lever in tailstocks on a lathe before, please let me know in the comments section. Like everything else with this project, it was dirty and rusty, but it basically worked just fine. And depending on the work that they did in that old workshop, it might never have seen much action in the first place. Like the other parts, it was partially disassembled and the parts were wire wheeled and repainted, and this is what it looks like now. Alongside the carriage, the headstock is the other part of the lathe that has a little more going on compared to many of the simpler parts we have already taken care of. It also was possibly the dirtiest part of the entire lathe, and I needed to clean it in several steps. Before doing anything else, I had simply sprayed it with penetrating oil and started to scrape off the thick layer of grime. In order to reduce weight and also to be able to disassemble it, I unscrewed the old 3-jaw chuck from the spindle. And since I saw no other way to clamp the spindle down, a ratchet strap was attached to that flat belt pulley. After removing the rust with acid, drying and oiling the parts, this is what a typical 3-jaw chuck of this type looks like from the inside. The piece that makes the jaws move to the center of the spindle is called scroll plate. And it is a specialized component that has a bevel gear on its backside, where typically 3 smaller bevel gears engage with it. A key fits into those gears and they are used to open and close the chuck. On its front side is a spiral-shaped or scroll gear. On the bottom of the jaws, you will find threads that fit onto that scroll, and that is how that works. After unscrewing the old nuts and lifting off the top part of their cast iron housings, we can see the spindle bearings for the first time. They are conical, split on one side, and look almost like they are made of brass, even though it is more likely a type of bronze. They are open on the top side, where a steel ring is sitting, free to move around. It's an oil ring bearing. The ring dips into an oil reservoir. This is new oil, by the way, that wasn't in there, and then revolves through that reservoir as the spindle turns, constantly taking up oil and lubricating the spindle rotating inside the bearing. Inside and outside of each bearing we find slotted round nuts used to tighten and adjust the bearings. They look like that has happened many times in the past, and maybe the former owners didn't actually have the right kind of wrench to turn these nuts. On the back side of the headstock we find the back gear. It is a reduction gear that can be used optionally for slow speed, high torque operation. The way it works is that the small gear here is mounted onto the flat belt pulley in a fixed position, while the big gear here is mounted onto the spindle directly. By pulling a small lever on its face, the pulleys and small gear are decoupled from the spindle and can now spin freely. Once you have done that, the back gear axle, which is sitting on an eccentric cam-like mechanism, can be rotated to engage with both gears, acting as a reduction gear between them, so between the flat belt where the power is coming from and the spindle where the workpiece is mounted. We will probably never use that feature, but more about that later in the video. But be that as it may, after lifting the spindle out of the casting and removing the back gear as well, I continue to disassemble the headstock. Inside we find a tumble reverse mechanism. It couples the lead screw to the spindle via the change gears. When in neutral position, the change gears and lead screw are dormant. The other 2 positions are forward and reverse, determining in which direction the carriage will move when powered by the lead screw. Except for the spindle, every part of the headstock was completely disassembled, and many of the parts were suspended in gasoline because they were so gunked up. The cast parts were wire wheeled and cleaned thoroughly. When degreasing parts with a strong solvent like that gasoline, they will be sensitive to corrosion afterwards, which means that they need to be oiled or greased for protection. By the way, the 2 V-shaped grooves in the middle of the old pulley are likely a modification. We can also see that a chunk of the cast iron here was ground off to make room for a belt that would not have been there in the original design of the lathe. And again, everything was degreased, taped and repainted, and then the headstock was reassembled. Except for a few details, all the original parts of the lathe had now been taken care of. But there still was the question of how to power the lathe and what to do with the old motor and gearbox. The actual age of the machine is uncertain. I actually called Tony, the owner of the famous website Lathe.co.uk.
It's certainly German. The tunnel reverse lever has got that so typically German controller. It looks to be circa sort of 1905, 1920 style.
Okay.
Probably a little bit younger than that.
And we had a very long, very nice conversation about this lathe and a few other things. So thank you again, Tony, for that. And if you are interested in the history of your lathe or just want to browse the different manufacturers, go to lathe.co.uk and see what you can find there. There is a lot there to discover. No matter if the lathe was made in 1905 or 1925, it didn't come with an electric motor when it was first made. In those days, many machines were still powered by line shafts or even treadle powered. When I had first bought this lathe, I believed it to be made by Oskar Ehrlich from Chemnitz, later known as Unionwerke, as you can see in this ad from 1939. Oskar Ehrlich machines were often sold under other names. They were also imported to Britain and sold under different names there, IXL for example. Here in Germany, they were sold by the well-known Berlin-based tools dealer Schuchert und Schütte. I even bought the Schuchert und Schütte machine tool catalog from 1928 and had a look at the machines inside. While they have many similarities to my lathe here, there are also many small differences. Independent of who actually made this particular lathe, the catalog also shows how electric motors can be fitted to these machines. As you can tell, these were often rather complicated contraptions. The motor and gearbox that came with the lathe were just such a contraption. Unfortunately, it turned out that the old motor still had bushings instead of modern bearings, and they were totally worn out. It was also electrically damaged and unsafe, and most importantly, it was underpowered for what I have in mind here. The old automotive gearbox was unfortunately literally falling apart, and there is sort of the reason why this project was stalled for so long. After buying the lathe, I found that the thread in the cross slide was worn out. The back gear had been damaged and fixed in the past. The change gears initially looked horrible. The motor was broken, the belts were rotten, etc., etc. Now, I wanted to restore the lathe so that fans of historic machines would be happy. But I'm also not in the luxurious position to have unlimited space here. I can only hold machines that will actually be useful in the workshop and that can pull their weight. Such a machine would have to be fully functional and powerful and also come with modern speed control features, for example. And while I had an idea of how to solve all these issues, I wasn't sure I would be able to do both and end up with a beautiful as well as a useful machine. For the longest time, I simply didn't know what route to take, form or function. Now, I know this is silly, but I was afraid ending up with a result that would satisfy no one. However, in those 5 years, I have worked relentlessly on learning new skills and have also been gearing up the workshop at an often brutal pace. I had learned more about computer-aided design and had built my own CNC plasma cutter, an extremely powerful combination. I had spent a lot of time practicing my TIG welding and also bought a milling machine and many other tools. I have pushed myself extremely hard to become more professional at what I do, and a few months ago I decided that I had what it takes to upgrade the lathe with a modern, more powerful motor with electronic speed control, making the old motor and gearbox redundant, yet create an aesthetically pleasing and even whimsical result. This German-made SEW 3 kilowatt 3-phase induction motor was spray painted gray to match the lathe better, and together with a Lenze VFD that a viewer had sent me a while ago, and thank you again for that, I would be able to have more than enough power at high or low speed, even without a gearbox. However, a custom attachment would have to be designed to fit the motor to the lathe, and the modern electronics would have to be housed in an enclosure that would also complement the elegance of this historic machine. So those were the next steps that I had to take. Now, the new motor is probably about 4 times as powerful as the old one. That doesn't mean that I want to push the old lathe, but it means that if I can slow down the motor with a variable frequency drive, it'll still have enough power even at low speed to operate the lathe. For that, I want to reuse one of the V-grooves on the middle pulley to connect the new motor directly. But I don't want to modify the historic lathe itself. I want to reuse the tapped holes that a former owner had already cut into the back of the machine bed a long time ago. By taking precise measurements, I was able to design a new mounting plate that will bolt right onto the backside under the headstock. In order to design a custom part like that and also get an idea of what it could look like once it's made, computer-aided design is worth its weight in gold. Since last autumn, I have partnered up with Onshape, and I have since done all my design work with their software. Without this strategic partnership, this project here would probably never have been finished. In its simplest form, this motor attachment piece could simply look like this, using only the simplest geometrical forms, but that would not sit right with me, as it would not harmonize with the beautiful curves of the old machine's cast iron body. The screen recording you see here is not the exact final design I used, but only a reenactment of some of the design work I did. As long as you take some measurements beforehand, drawing a sketch and extruding the parts, creating a 3D model of a welded part like this is actually fairly easy. You basically just have to create two-dimensional drawings in different planes and extrude them. If you don't like the first draft, you also have the option to modify the extrusions directly, independent of your initial sketch. Since CNC plasma cutting is essentially a two-dimensional process, the three-dimensional model is not strictly necessary, as you basically just trace the outlines of each part and project them on the same plane. However, in order to check if these components will actually fit to each other correctly, a 3D model is key. In a few minutes, we'll need Onshape again to make a second part. In my humble opinion, the software can be used for professional projects. If you want to try Onshape yourself, please use my link under this video. If you're curious anyway, maybe just try it. It would help out this channel a lot. If you are an engineer, you can get a professional license for 6 months for free, or for everyone else, there's also a free version available. But now, let's start fabricating that attachment. Once the plasma cutter is set up, it does most of the work itself. However, even after separating the parts, there is still some work to do, because there's always some dross on the edges of these plasma cut parts that need to be beaten or ground off. This is also the first chance to actually place the different components together and see if they fit. There were also still holes to be drilled. Now, you can do this with plasma cutting as well, but in this case it wouldn't have been very precise, so I've been doing it with the milling machine instead. And here we can see that that plate actually fits over the 4 bolt holes. The big mounting plate that will hold the motor unfortunately has a lot of old holes in it because, well, it's a piece of scrap. So what I did is to actually take the time to weld them shut by TIG welding. And after that, I clamped it down in the milling machine to machine down those welds. And after that, I also sanded them down until they were really smooth. Now, every one of these steps took a pretty long time to set up and to do in reality, while it's happening in seconds here in the video. The parts were then arranged and tack welded and mounted to the lathe for the first time to see what it would actually look like, where exactly the motor needs to be placed, and so on. So after this, we walked back over to the milling machine, this time to work on the motor housing. See, in its former life, it was mounted by its flange to whatever it did before. But we need holes at the side of the enclosure to bolt it down onto the attachment. So we drilled and tapped it here. Also, in order to tighten and soften the belt that connects spindle and motor, we needed to machine 2 slots in the big part of the motor attachment. And of course, we did that once again with the help of the milling machine, an incredible versatile piece of equipment. Intermittently, I connected it to the machine again just to see if these slots were actually at the right position so that the motor could be aligned with a spindle. So after checking once or twice, I then finished the TIG welds. I sanded the entire attachment and spray painted it in the same kind of paint that we used for the machine before. And the attachment is now finished, and here's a little comparison between drawing and reality. So the attachment was then permanently bolted to the machine bed. Bolts were inserted into the 4 holes in the motor's enclosure, the belt was put under tension, and the motor was fastened in place. With the bearings already adjusted and oiled, the lathe was now, for the first time in 50 years, principally back in action. However, there were still a number of things to do before it was really ready to go and fully functional. In order to house the VFD and other electronic upgrades, this old enclosure here will be repurposed. For that it was first degreased and painted in the same color as the lathe, and while the paint was drying, a few other things were prepared. In order to honor all the blood, sweat and tears that went into this project, I don't want a run-of-the-mill enclosure. It has to be one of a kind. I recently found a bunch of these huge neon bulbs here that were made in the Soviet Union on an online marketplace. I bought a couple of them and decided that I wanted to build something cool with them. See, for safety reasons, I want all my machines to have really big and visible red indicator lights that show when a machine is powered on or even just in standby. And these neon bulbs are so cool that I just knew that they would be great for that. In order to add some panels for lights and switches to the old metal enclosure, I came up with a design for a modularized system for enclosures and front panels that can be made on a 3D printer of standard size. A frame of 200 by 200 millimeters can hold 4 100 by 100 millimeter panels that can hold indicator lights, switches, buttons, meters, or in this case, ridiculously sized neon bulbs. This is something that could be customized for other unrelated projects in the future. I printed a variety of these panels and decided to spray paint them silver because all I had was black filament. Sockets were installed, bulbs and switches screwed in, and everything was wired up. The VFD and a big EMI filter were also installed inside the big metal enclosure. There's a lot of space here for contactors, relays, and other upgrades that I'm already working on. In the meantime, the rust on the change gears had been removed and the gears had been oiled. I also designed a tray for the gears in order to store them. A combination of gears were then installed at the back of the headstock, and the lead screw was now once again back in action as well. The indicator panels that also hold a potentiometer and switches that are connected to the VFD were bolted to the top of the old metal enclosure. And with all that out of the way, it was finally time for the moment of truth and the first chips in 50 years.
Sure, now stand up and sing for your father an old time tune. Please stop that crash that you sing morning, night, and noon. Oh, I'm sick of all these cities about moon and spoon and shoon. So will you stand up and sing for your father an old time tune?
So, this is the conclusion of a project that started 5 years ago that I had almost given up on. And I hope that this will serve as an inspiration to some of you, as well as to myself in the future, when I look back at this, reminding myself that it is never too late to turn around and make a change. I would like to tell you more about the upgrades that I'm working on. Maybe even make some decisions on safety concerns with open gears and belt drives. And I would also like to show you more machine tool restorations and projects, as I mentioned earlier in this video. However, when looking back at this project and the absolutely insane amount of work that went into it, a lot of that kind of depends on the success of this project and this video. I need strategic allies to be able to keep on going and even dig deeper into stuff like this. And there are a number of ways you can be such an ally. For example, by using my link under the video and try Onshape for free. You can also make a donation via PayPal. There is a link for that under the video as well. And there is now also an IBAN banking account, especially for donations under the video. If you are in Europe, that is an even better way than PayPal to support the channel. And talking about allies, past, present and future, I also have a message to my viewers here in Germany. So let me say it in German. Ich suche seit einiger Zeit aktiv nach Handwerksbetrieben hier in Deutschland, gezielt auch nach Menschen mit Meistertitel, am besten im Metall- oder Elektrobereich in Deutschland, die vielleicht Lust hätten, sich irgendwann in der Zukunft mit mir zusammenzusetzen, zu vernetzen oder einfach ein Bier zu trinken. Es geht um eine mögliche Zusammenarbeit, über die ich euch dann gerne privat mehr erzählen kann. Ich selbst wohne in Köln, freue mich aber über Nachrichten aus ganz Deutschland. Falls Interesse besteht, schickt mir doch gerne eine kurze E-Mail an gerokeber@gmail.com. Ich freue mich, von euch zu hören.